Hello, this is mathjazz from Almost Cool. This is our 6th derivative quiz video. Our topic today is related rates. I'll read the questions to you, and then you can pause the video to work out your solutions. Afterwards, you can unpause the video and see if you got your answers correct. Problem 1. Suppose a spherical balloon is being filled with air at a rate of 1/8 cubic feet per minute. Suppose also that the balloon is empty at time t equals 0. A. Give a function for the rate of change of the radius of the balloon. B. What is the radius's rate of change at t equals 16? 2. Suppose that a conical vat with base radius 5 feet and height 10 feet and vertex pointed down is being filled with water at a rate of 1/2 cubic feet per minute. Suppose the vat is empty at time t equals 0. A. Give a function in h for the rate of change of the depth of the water. B. What is the water depth's rate of change at t equals 10? Here's a diagram for your convenience, and the equations for the volumes of spheres and cones. And now on to the solutions. 1a. Give a function for the rate of change of the radius of the balloon. Since v equals 4/3 pi r cubed is the equation for the volume of the sphere, taking the derivative of this gives a relationship between the rate of change of the radius with the rate of change of the volume. So, we get dv dt equals 4 pi r squared dr dt. If we solve for dr dt, we get dr dt equals 1 over 4 pi r squared dv dt. And then, if we plug in the rate of change of the volume, which is 1/8 cubic feet per minute, we get dr dt equals 1 over 32 pi r squared. 1b. What is the radius's rate of change at t equals 16? If we plug v equals 2 into the equation for the volume of the sphere, and get 2 equals 4/3 pi r cubed, we plug v equals 2 into the equation for the volume of a sphere and get 2 equals 4/3 pi r cubed. So r equals the third root of 3 over 2 pi. The reason that we did this is if the volume of water is increasing at 1/8 cubic feet per minute, then at time t equals 16, we have 16/8 or 2 cubic feet of water in the cone. And our equation for the change in the radius, the change in the depth was left in terms of the radius. So we need to figure out the radius, so we plug 2 into the volume equation and solve for radius, and that's how we get r equals the third root of 3 over 2 pi. We plug this into the derivative we got from part A, and we get dr dt equals 1 over 32 pi times the square of the cube root of 3 over 2 pi. And we'll leave it like that. Simplifying fractions with radicals in it will be at a video for another day. 2a. Give a function in h for the rate of change of the depth of the water. First, we find a relation between the radius and the depth of the cone of water. Here's a diagram to help us do that. We notice that the sides of the cone can be thought of as a line with a slope of 1/2, or depending on how we orient the cone. In this case, actually, it's a slope of 2. That is, the radius 2 times the radius is equal to the height of the cone at any point. As we go over 5 in our radius and up 10, and we lie on the side of our cone, any distance that we go over in our radius, we go up twice that to lie on this edge of the cone here. And so our point on the edge of the cone is going to be a point r comma h. R is the radius, h is the height, but that's going to equal half of the height comma the height. And so when we plug r equals 1/2 h into our volume equation for the cone, we end up with v equals 1/3 pi times the square of h over 2 times h, which is equal to 1/12 of pi times h cubed. Now if we take the derivative of both sides of this equation, we get dv dt equals pi fourths h squared dh dt. We solve for dh dt, we get dh dt equals 4 over pi h squared times dv dt. dv dt was 1/2 in the problem, so we get dh dt equals 2 over pi h squared. Part B was, what is the water depth's rate of change at t equals 10? So we plug in t equals 10. Well, we recognize that since the water is pouring into the cone at a rate of 1/2 cubic feet per minute, then when t equals 10, we've had 10 halves of a cubic foot of water, which is 5 cubic feet of water, pour into the cone. So we plug 5 into our volume equation and solve for h. So we get that h is the cube root of 60 over pi. We plug that into the derivative that we got from part A. So we get dh dt equals 1 over 2 pi h squared, which is 1 over 2 pi times the square of the cube root of 60 over pi. And this is the rate at which the depth is changing at the time t equals 10. Thank you for watching this video. Contact information is on the screen. It is also in the description down below. I hope that you're enjoying learning calculus. I hope you did well on this quiz. And I will see you later. Have a great day. Goodbye.